Square root functions. We're going to rely a lot on transformations in order to graph these. They're really similar to the quadratics we're used to doing. They have a similar shape and feel, but they're special because when we look at the domain of a square root function, I know that no matter what I plug in here, if it's a negative result, I can't take the square root and my function stops working. And that's what this is talking about, the radicand, so that's the information underneath the radical, is greater than or equal to 0. I can take the square root of 0, but I can't take the square root of -1 and have anything to plot or have anything that I can work with in the real world. Okay, so we're going to graph. Start with the parent function, y equals the square root of x. Well, if I think about a table, I want to pick some numbers that I can use that I get nice integers because they're easy to plot. So 0 is going to work. The square root of 1 is 1. If I try to take the square root of 2, I don't get a nice integer value. It's not going to be easy to plot, so we're going to skip it. Square root of 3, skip it. Square root of 4, though, is 2. Square root of 5, 6. The next perfect square we can think of is 9. That gives us 3. So when I go to plot these points, 0, 0, 1, 1, 2, 3, 4, 1, 2, that's all I've really got space for. It starts and stops right here. But as we increase, that side is infinite. And so here's where we talked about our domain. It very definitely stops right here at 0. So our domain is going to run from 0 to infinity. It's one of the few functions that the domain is not all real numbers because it can't cross over and make this information back here be negative. Okay, so this is the square root of x. If I look back at my function that we want to graph, as with everything else, this inside tells me it's moved to the left 2, and the outside tells me it's moved down 3. Now, this is why we're going to want to make friends with this information right here. So when I get ready to do this, I'm going to take this point and I'm going to go to the left 2. And then from there, we're going to go down 1, 2, 3. And we're going to treat this like it's our new 0, 0. We've got our fake x-axis and y-axis, and I'm going to come right back here and use the same exact pattern. So from my new 0, 0, we're going to go over 1, up 1, 2, 3, 4, 1, 2, and graph my new square root of x plus 2 minus 3. And if I go back and check, all of my points have been moved, right? 1, 2, 1, 2, 3, there it is. 1, 2, 1, 2, 3, there it is. Then I only have to apply my transformations the one time to get my new graph. Now, from here, my domain and range. And because I lightly put these axes in here, it's a lot easier to tell what my domain and my range are going to be. My domain, remember that's from left to right, because it's always minimum to maximum. So if I go all the way to the left, it's at -2. There's a point there. To the right, it's infinity. And my range, always from the bottom to the top, because again, minimum to maximum. I drew my cutoff down here, that's at -3. And as we move to the right, it continues increasing, positive infinity. Okay, we're going to do the same exact thing with inequalities. Same exact process. Okay, so when I am working on graphing this, I'm going to come back in and put my original function, 0, 0, 1, 1, 2, 3, 4, 2, so that I have a way to anchor it. Okay. And then when I'm looking at this, I know it's moved to the right somehow, but we haven't done a lot of work with this 2x right here. So we're gonna cheat a little bit, use a calculator to get a table. But I do know that it's gone up too. So wherever it is, the bottom of this function has moved up 2 units. And I know that because this is less or equal, once I do get my picture, it's going to be solid, and we're going to shade up. Everything above our line. So grab a calculator. And we're just going to type that in there. Y equals square root 2x minus 1. Get out of the radical. If you're not really careful to arrow out of there, you're going to cause yourself some problems later on. Plus 2. And then there are all those errors. So this is everything that makes it be 0 or that less than 0. Okay? So the first point I can see that I can plot is this 1, 3. Which, when I go to 1, 2, 3, we had said it was going to move up 1. And then 5, 5. 4, 5, 1, 2, 3, 4, 5. But this isn't 2 above. So I still haven't accounted for the movement to the right in this. So I need to figure out where this is actually terminating, where this ends as we trace it. So if I look along, once I get to this point 2, my y value stops showing up. When I'm at this point 6,3, my y is 2.52, which still doesn't help me figure out what's going on right here any, because the decimals are too weird. So we're going to go back to our definition that the radicand is greater than or equal to 0. And we're going to take this 2x minus 1, set it equal to 0, and we're going to figure out what it is, where that point is exactly. So 2x equals 1, x equals 1/2. So I know that when x is 1/2, this is 0, so y is 2. So I'm going to go to 1/2, 1, 2, and now we can see more of our curve, what our graph is supposed to look like. Okay, and because it was less than or equal to, I even wrote that down, less than or equal to, so we're going to shade down. So from here, straight down, straight down, straight down. I can't go past this halfway mark right here. None of those points work, but everything else in this area does. And this is what my graph looks like. You've got to be very careful that you drop this straight down where it goes and everything underneath it. Okay. There's our graph.